I was prepared to run this on Ubuntu, but as you saw, I have problems with the display, so I'm running now on Windows, and maybe things don't look as expected. But, for example, this. Okay, it's good enough. So, I can't sit, so I have to stand up. My name is Nicolas Paez. I'm software engineer working for Southworks, and I'm teacher assistant at the University of Buenos Aires, engineering faculty. And during the last 3 months, I've been working with our mod team at INRIA, France, working on this project called SEED. And, well, it's not what I'm going to present now. I want to tell you what we are trying to do with this project. Well, this is a little bit about myself. So let's start talking about the problem. Why we need a kernel? The goal of our project is to create a new kernel. And why? We are working on Faro. Faro was based on Squeak, and Squeak image has a long time evolving. I mean, the first version of the image has many years, and everybody has started adding code there. So if we look at at the image, we will find some code that is not happy, maybe. And if we start analyzing the package structure, we will find some undesired dependencies between the packages. And so we want better modularization to fix those smells. At the same time, we would like to reduce the image size, because there are so many things inside the image that in some occasions we don't need. For example, a very common case in these days, if you want to run CSI, for example, you don't need a UI to run CSI. You can run CSI with a headless image, but if you try to remove Morphic, for example, today, it's not an easy task in the current image. And at the same time, continuing with this CSI example, we would like to create custom images, loading inside the image only those packages that we want to run, right? We are not the first one trying to do these kind of things, I mean creating a small image. But we have a special vision. In this project we want to create a minimal clean kernel able to evolve into a fully functional system. What we mean by fully functional system? Well, the current image, if you take the core image of Faro today, is a fully functional system in the sense that it can evolve. We can add classes, we can expand the image and add new functionality. And we want to have a really small image. I don't know if you are aware, but today we have two images of Faro, the dev image and the core image. That is a reduced one with less tools, but it's more or less the same. As I told you before, there's been other projects with similar goals along the time. So we started by reviewing these existing projects, and we found three things that distinguish this project from our project. The first case is that some of these previous projects use a special VM. That was not acceptable for us. We want this new kernel image to be able to run in the current VM. So we discarded those projects. Another thing that we found is that some of these existing projects has different goals. For example, I will talk about these projects later, but just to mention one, there's a project called Microflick, that the goal of the project was to create the smallest image possible, and they do a good job with that. But that small image wasn't able to evolve because there was no compiler inside the image. So you can do nothing with that image. You just create the image, you put some code inside it, like a main in C, and the image cannot evolve. So that was not acceptable for our goal. And the third kind of project we found are projects that has no more support. There were some proof of concepts, for example, or maybe they were developed in an experimental environment, and they did the experiment, and it was abandoned there. So if you want to use that, well, it will be very difficult because nobody is supporting that. That's why we decide to start with our own project, considering all these previous projects that has been developed before us. So this is our team. The director of this project is Stefan Ducasse. We have 3 engineers, Benjamin, Gabriel, and me, and 2 collaborators, Marcus and Pavel. This is the team that is currently working on this. We know that it's a long way, and we have defined a roadmap, and we will be, I will be sharing this roadmap with you. So, here is the context of the problem we want to solve, right? We want to create a small image, and there are some interesting things to consider when we face this challenge. So, let's start with some basic things. What's inside the image? If we look at the image, what things can I remove from the image is the question. I mean, we won't touch the VM. So when we run Faro, or Squeak is the same, the VM expects some things inside the image. If the VM doesn't find certain things inside the image, it won't run. So the first challenge is, well, what is needed by the image to run? We can basically summarize this into 3 kinds of things. First of all, we will need the system dictionary, right? There is the definition of all the classes of my system. Another thing that we will have, there are some special objects inside the image, like nil, true, false, and some more. And then we have some other objects, right? The special objects are those defined by the special object array, that is a certain space inside the image. And there are some common objects that are not referenced by the special object array, but are present in every Smalltalk, like the workspace, for example. So, let's now review some interesting things that we found when encouraging this project. So, what should we put inside the new system dictionary, right? Yeah.
Is this kernel headless, or is it kernelless, or has some support for Boolean?
Well, the first thing I must say is that we don't have a kernel yet. We are working at this, and we are thinking in having 4 different kernels. One of them, or 2 of them, will be headless. Another one should be something interactive, like GNU Smalltalk with a console. And the last one should have a UI. I will talk about this later. But continue with the flow. I mean, we want to create a new image. We know that inside the image should be a system dictionary with the definition of the classes. Okay, what classes should we add to that dictionary? Well, the first things that came to my mind is, well, there should be an object class, meta-class, behavior, true, false. Well, how many things? If we take a Faro core image today, there are more than 3,000 classes. Do we need 3,000 classes? If we take Microflick, there's only 50 classes. There's a huge difference. But this is interesting because if we decide, okay, maybe we don't need to put display into my new image. Okay, but there are many objects that are referring to display. So if we remove display, what should we do with all those things that refer to display? Those are decisions that we have to face. Another thing is, how do we populate this new dictionary, right? I want to create a dictionary for my image. How do I populate this? Because one could say, well, I just take my current dictionary and copy things into this new dictionary. But the things I copy, maybe they are referring objects outside that dictionary. Should I have literals and some stuff referring things outside that dictionary? So it's not so easy just copy things from one place to another. I should copy the things and recompile this new dictionary to ensure that only references things that are defined there. Some more things. How do we ensure that the resulting image is complete? Suppose I create a dictionary, I populate the dictionary, and then I follow the certain steps required to save the image. Okay, I save the image, but how can I be sure that that image is complete and that it's enough to run, and if I send a message to an object, it won't crash? Well, it's a challenge. Well, another thing, how to make the resulting image able to evolve. If I have a compiler inside the image, well, I can use the compiler to generate new features, but maybe I don't want to put the compiler. But I want the image to be able to evolve. So what other options I have? Well, another option could be just load binary code inside the image without loading the compiler. Well, there's another team in INRIA working on that. Some more things. This is one of the most interesting. We are working on Faro. We want to define a kernel for Faro, but Faro is still evolving. There's a whole community working on Faro. We can't tell the community, hey, stop working. We are going to create a new kernel. That's not acceptable. So this is another challenge we are facing. We are trying to define a kernel for Faro while Faro is still evolving, right? So, till now are some of the challenges we face. Now I'm gonna tell you about some of the projects that we review after start our work. Well, not after start, before start. I mean, when we start with this project, during the first month, more or less, we just review existing projects. And this is a summary of the most important projects that we found. The first one is Kernel Bootstrap. Kernel is a PhD student in France that is working on security concerns. And he takes a GNU Smalltalk and he creates a new virtual machine to support something that he calls object spaces that are like security contexts. And what he does is he loads a definition of his object model. I mean, definition of object model means he defined his own object class, his own method model. He loads that method model into a image, and then with those definition, he writes a new image with these classes. But this new image is not compatible with the common VM. He has his own special VM, and when his own special VM loads this image, it can reproduce the image. It can bootstrap itself, right? It's an interesting job because the new image is just 100 kilobytes, really small. But the restriction here is that this VM is not a common VM. It's a GNU VM modified by Kernel to support object spaces. So the object format is totally different. And we took some ideas from this project, but it's not compatible with our goals, right? Another interesting project is Microflick. It was created by John Maloney in 2004 using a Squeak 2.8, I think. And it is a very good implementation. he wanted to create the smallest image possible, and he did it, because it's just 56K. Really, really small, and it has about 50 classes. If we look at this, you can run this. It's published under MIT license, I think. And the strategy is quite simple. He has a dev image that is a Squeak 2.8. He has his own definition of classes. He has his own object, his own class, and all the meta model. About 50 classes. And what he does is he just creates a new dictionary. He puts all those classes there, modifies some references to literals, recompile that, and write a new image. And, well, something interesting is what he does with the things that he don't include there. For example, his image has no display, no morphic, no nothing, no compiler, nothing. He just modifies the startup, and if you want that image to execute something, you have to write a method that it's called system startup. It's like a main in C. So you put your code there, you save the image, and when you run the image, it executes that method, like a C program. So that image cannot evolve. It's like a C program. When you code it, you compile it, and that's the problem. That's the program. It does not evolve. Well, but it's what John Manoli did, and it's an interesting implementation because it gives us an idea of what is needed. And something very, very interesting is that this image was created using Squeak 2.8, but we can run this with the current VM. It's been a long time since the time when when John Maloney developed this. I think that the VM in that days was, I don't know, maybe version 2. Now we are in 3.8, I think, and it's still running. So you can download it and run it, and you will get a really small image. Okay. What else? Chacharas. This is a very interesting project. Chacharas has two approaches. One called Gestation, that is very similar to Microsquick, but maybe not so efficient. And it has another strategy called Nutrition. The strategy is very interesting. What he uses a special VM, and inside that VM, he can load two images. So he has the host image and the image he wants to create. Inside that image, he puts some classes. I mean, the classes of your application. And once that he has this new image with the classes of your application, it starts running the new image. And when he detects that it's something missing, he communicates to the host image and grabs what is missing. For example, to be clear, suppose I want an image that just has two classes, foo and bar. Right? So he creates a new image, and in the dictionary he just put two classes, foo and bar. When he tries to execute foo and bar, it detects that foo inherits from object, but object is not inside the image. So he communicates with the host image and grabs the code of the object class that were missing. That's the approach. Yeah.
I think that Spoon had a different approach, because in Spoon you run the main image and you mark the method that you need.
Yes.
And you run your application and generates an outcome.
Yes. In Chacharas it's the same. I mean, if we look at the implementation details, it's like you say. In fact, the difference is how you mark what you need. In one case, for example, Spoon uses the garbage collection to mark what is needed. And Chacharas does not use the garbage collector to mark what is needed. It takes an array where he puts and write a log of all the things that were invoked. But I mean, the general idea is more or less the same. You have to execute your program to detect what is missing, and then populate the image what you detected.
And you have to execute hard enough so that you get everything you will eventually.
Yeah, that's one of the difficult things, and that was one of the questions I mentioned before. How do you know that the image is complete? Maybe you forget to run a certain path in your application, and some methods won't be populated there. So it's an interesting thing. And well, the other issue with this project regarding to our goals is that it requires a special VM. But it's a very interesting approach, and we consider this to define our strategy to create our kernel. So, one more. Pavel kernel. Pavel Krivetsky is working with us, and he has a very engineering approach. What he does is he took Faro standard image, he takes a scissor, and he starts cutting things. He removes a certain he removes all the packages except those that he considers important. It's more or less that the approach, right? If we look at Faro today, it has more than 3,000 classes, and he removed packages. What he does is just shrink the image, removing packages, and then save the image without those packages. Of course, in the middle, he has to fix some references, recompile things, and modify. For example, he removes Morphic. So instead of having a UI manager, he has a dummy UI manager, right? The problem with this approach is, how do you know what you can remove? Maybe you are removing things that are not removable because everything will crash. So what we ask him is, how do you know what you can remove? Well, it's just try and error. Just try and error. So by hand, he has a set of tests, and he removes something, run the test, and well, it seems that it's working, and that's the way. And the problem with that is that Faro is evolving at the same time. So he has a lot of scripts, not a lot of scripts. I think that there are 10 scripts, more or less. So when you want to create a Pavel kernel image, you take the Faro image, you run those scripts, and you get a resulting image that is about 2.3 megabytes. The problem is that Faro is evolving, so if you run this with one build of Faro, it can run, okay, without troubles. But if you take another build, a later build, maybe it won't run. I mean, it will run, but the resulting image won't be complete, right? But this work is very, very interesting and very important, because thanks to this we can identify some smells in the packaging structure. For example, when Pavel started working, he started reporting us what things he needs to be repackaged. I mean, for example, I'm not sure if we fixed this already or not, but I think that there was something like exception class depending on UI manager, or depending on something related to Morphic, and conceptually that's not good, right? We found several things of that concerns, right? For example, something very common. There are many classes that it has a method called asMorph. And why? Morph is related to UI, and there are many classes that are not related to UI. Why they have a asMorph method, right? So based on this work, we start repackaging the structure of Faro, moving methods around to prevent these undesirable dependencies. So I think that these are all the projects we review, and that we consider when defining our strategy to create our new clean kernel. So, our strategy, I didn't mention it before, but I think that it's quite obvious, is working on the image size. We won't modify the VM. We will leave the VM modification to Elliot. I don't know if he is around here, but we exchanged some emails with him. He has an idea of what to do with the image related to what we are doing. I will mention this later, but we will focus on manipulating the image. We won't expect any modification in the VM, and we decide to create 4 different kernels. We have some code names for them. The smallest one is called Pine kernel, and it's just migrating Microflick to Faro. Microflick is based on Squid 2.8, and we want to make it run in Faro 1.2 or 1.3. There are some changes there that we are fighting today. And there are some things in Pine kernel that we don't like. For example, the goal of Pine kernel was to create the smallest image possible. And because of that, they did some things that conceptually are not good. Or I don't know if they are good or not, but we don't like them. For example, you don't have a Boolean class in Pine kernel. You have true class, and you have false that inherits from true. I don't like that. And our goal is not to have the smallest image possible. We have a smallest image, but according to some good practices, let's say. So we will include a Boolean class and true and false as descendant of Boolean. And we have some other things similar to that. For example, there was another issue related to association and point. There are 2 different classes, but from the memory point of view are the same. It's a class with 2 slots. Well, in Pine kernel you don't have association and class. You have just association and point. You just have point, and point is used also as an association. That's not, well, it makes sense if you want to reduce the number of classes, but not in our case. I'm not sure if it was exactly that, but it's more or less the same situation. You have some things of that stuff, I mean, that we will modify.
But true as a class of false is very interesting.
Yeah. And, well, the idea is that this Pine kernel will be just for teaching purposes, right? If you want to teach meta-modelization, for example, it would be interesting to use this Pine kernel. Hasselnet kernel is bigger than the Pine kernel. It's not based. We think that we will have to start working again. We won't use the same code baseline that Pine kernel, and we want to introduce exceptions. Pine kernel does not have exceptions. We want to introduce exceptions, and we want to introduce announcements. And it's not clear the goal of these 2 kernels. We think that Coconut should be the fully functional kernel, able to evolve. That means with a compiler or with a binary code loader or something like that. And this one in the middle should be able to include some interactive environment like a console or a UI. But we know that we want to separate the kernel from the interactive stuff. The idea is you have the kernel. If you want to run this with a console, okay, you load a package that enables the console. If you want to run this with Morphic, you just load a package to load Morphic. But it should not be a dependency inside the kernel. We want to leave those UI stuff outside the kernel. Okay, some more things about this. We are working in 2 branches. On one side, we are working on package remodularization. In this case, we are working very close with Pavel. And on the other side, we are working on the kernel creation based on Pine kernel, creating the kernel from scratch. And we think that if we work in both branches at the same time, we should arrive to coconut kernel from both branches. That should be the point where both works meet, right? In parallel is what I mentioned about Elliot VM. I don't know if maybe we can ask him later, but he has an idea of, I think he mentioned this morning, modify the VM to support 64-bit architecture and at the same time support arbitrary object formats. That would be very interesting. And add some mechanisms into the VM to be able to bootstrap a full image. That's something that we don't have today, and it's possible because GNU Smalltalk has something like that. Well, where we are? Well, we consider that we have completed the research work. I mean, we have reviewed all the existing projects that we consider relevant. If you know about any project related to this that I omitted, please tell us. We have built some support tools to help in the remodularization. We have wrote some scripts to create a new image. And at the same time, we are working on engineering work, right? Remodularization Faro packages and with the migration of Microflick. No more. Okay, if you want to collaborate with this, you can do it. For example, you are working with Faro and you detect that there is an ugly dependency between two packages. You can create an issue and tag it with seed. So the seed team, we are looking for those issues and we try to solve them. So you are welcome to collaborate with us. And if you want to see what we are doing regarding to code, there are some tools that we are building to help in this work. You can go to Squeak Source and look for seed, and that's our repository, of course under MIT license. Pine kernel is there. It's not working right now, but what we have is uploaded to this repository in Squeak Source. And I think that this is all. Well, there's the contact information if you want to contact me or Steph, that is the director of the project. And well, here is the information. This is an internal repository. You won't have access to this, but I think that in one point we will publish it in some other place. Well, that's all. If you have questions.
Okay.
Thank you.
Half an hour break.